In this video, we're going to discuss one of the colligative properties, vapor pressure lowering, specifically for a non-volatile solute. Colligative properties depend on the number of the solute particles dissolved in solution, not the type of solute particle dissolved. In other words, these properties are dependent on the concentration, but not the identity of the solute. Remember that the vapor pressure of a pure solvent is defined as the pressure of a gas when it is in dynamic equilibrium with its liquid state. The term dynamic is used to describe equilibrium because the molecules in the system are constantly in motion, condensing and vaporizing. However, the rate of vaporization is equal to the rate of condensation at dynamic equilibrium, meaning that the number of molecules in the gas state and the liquid state remain constant, although they aren't necessarily equal to each other. Therefore, the vapor pressure of a pure solvent is a constant value. However, what happens upon the addition of a solute to a pure solvent? For instance, if a non-electrolyte non-volatile solute is added to the solvent will interfere with the ability of the solvent to vaporize. Therefore, the rate of vaporization will decrease and the number of solvent molecules in the gaseous phase will decrease. At this point, the rate of condensation is greater than the rate of vaporization. To re-establish equilibrium between the rate of vaporization and the rate of condensation, the gaseous solvent molecules must condense. As they condense, the reduced number of molecules in the gas phase allow for a decrease in the rate of condensation. Eventually, dynamic equilibrium is achieved and the number of molecules in the gas phase have reduced. Since there are fewer molecules in the gas phase, this reduces the pressure of the gas at dynamic equilibrium. Therefore, the vapor pressure has decreased in comparison to the pure solvent. We can quantify the vapor pressure of a solution using Raoult's law. By definition, the vapor pressure of the solution is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. Remember that the mole fraction of the solvent is equal to the moles of solvent over the moles of the solvent plus the solute, in other words, the moles of solution. In order to determine the decrease in pressure that has occurred upon the addition of solute, termed vapor pressure lowering, the vapor pressure of the solution is subtracted from the vapor pressure of the pure solvent. For this calculation, P of solution and the vapor pressure of the pure solvent must be at the same temperature and be in the same units. In this problem, we are told that we have a solution containing ethylene glycol and water that has a vapor pressure of 7.88 torr. Pure water has a vapor pressure of 9.1 torr at 10 degrees Celsius. We need to find out what the mole fraction of ethylene glycol is in this solution. So first, we need to recall Raoult's law, where the vapor pressure of the solution is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. So let's plug in what we know. We know that the vapor pressure of the solution is 7.88 torr, and the partial pressure of our pure solvent, water, is 9.21 torr. Notice how the vapor pressure of the solution has decreased due to the addition of solute. We do not need to convert the units of the vapor pressure because both are given in the same units, and both of these vapor pressures are provided at the same temperature. We can isolate the variable, the mole fraction of the solvent, by dividing by 9.21 torr on both sides, giving us the unitless mole fraction of 0.856. This is a reasonable answer because it's less than 1. But wait! The problem asks us to find the mole fraction of ethylene glycol in the solution, which is the solute, not the solvent. So then we need to recall the mole fraction of our solvent plus our solute has to be equal to the total solution, and therefore it is equal to 1. Plugging in the mole fraction of the solvent and then subtracting by that value 0.856 on both sides to isolate the variable, we solve for the mole fraction of the solute, ethylene glycol, to be 0.144. Now, considering the same solution, we're asked to find the vapor pressure lowering, indicated by the variable delta P. If you recall, the vapor pressure of the solution subtracted from the vapor pressure of the pure solvent will give us the change in vapor pressure. Therefore, we can simply plug in the given vapor pressure and determine that the vapor pressure lowering is 1.33 torr. Overall, in this video, we have learned why the vapor pressure of a solution is less than the vapor pressure of a pure solvent. Remember that the vapor pressure lowering property is a colligative property, meaning that it is the amount of the solute, not the identity, that affects the change in vapor pressure. By applying Raoult's law, we can determine the vapor pressure of a solution and the value of vapor pressure lowering.